Thanks again for inviting the project to this session. I will try to fit to the purposes of the meeting. So first of all, I will give you an overview of the project, then focus a little bit on the standardization activities, and then I will be open to answer potential questions. So, well, just beforehand, I'm Álvaro Nofuentes. I work for the company ETSI Research and Development. We are the coordinators of the OPENTUNITY project. And going into more details about the technical specifications of the project, the OPENTUNITY project and the technologies that we are developing can be seen as a digital ecosystem in which most of the partners of the energy sector can collaborate and get innovative technologies. We are addressing mainly grid level actors, mainly DSOs and also TSOs. Also at the electricity market level, we are providing technologies for retailers and aggregators, and even we have a local flexibility market operator. Then in the side of consumption, of course, we provide technology to small and also medium and large prosumers, and also we have also some specific technologies for manufacturers. All these technologies are, let's say, categorized or divided into 4 different areas. OPENFLEX, OPENGRID, OPENSPACE, and OPENABILITY. These are not product themselves. They are like a kind of umbrellas in which different innovations are included, just for facilitating understanding or the dissemination to external. But each of these categories has a lot of technologies inside. I will give more details in next slides. But just in a few words, OPENFLEX provides technologies to the retailers, aggregators, and the prosumer level. OPENGRID provides technology to the grid level. OPENABILITY are not technologies itself, they are methodologies that mainly provide support to the DSOs and to the manufacturers. And we have OPENSPACE, which is an energy data space, which provides which facilitates the data sharing mainly between prosumers and the electricity market actors. Giving some insights about the administrative data of the project, let's say. The project started in January of 2023 and will finish at the end of December of 2026. And this means that we have just past the middle of the project. We are focusing on finalizing the technical developments, and the focus mainly for the end of this year and the next year will be on demonstrating the activities in real life and also evaluating the impact of the project. We are a consortium of 21 partners from 7 different countries, and we have different kind of partners like grid operators, of course, technical developers, market players, and also some research and standardization entities. The project has a budget of 12.8 million euros, and talking more in detail about the demonstration sites. Well, OPENTUNITY is an innovation action, so of course we need to demonstrate our technologies in real life conditions, and we have 4 different pilot sites. The first one is located in Spain, in which we cover a couple of small cities, and this pilot site mainly focus on improving the operation of the distribution grid in order to facilitate the integration of more renewable energies. In Switzerland, we have a small pilot in a small area of Lugano, specifically in the city of Massaña, which is close to Lugano. And the goal of this pilot site is to facilitate the settlement and operation of new local energy communities. Then in Slovenia, we have the pilot sites of some portions of the grids of two DSOs, Elektroprimorska and Elektroljubljana. And the main goal there will be to utilize or try to leverage the potential of flexibility that domestic assets, but mainly a large fleet of electric vehicles can provide to the grid. And finally, we have in Greece the Mesogia area, in which we will focus on increasing the digitalization and the DSO-TSO cooperation, mainly talking about the operations of one substation or one medium voltage high voltage substation. Talking about the technologies, well, OPENGRID, the technology for the grid operators, we can, let's say, highlight low-cost real-time thermal rating, which is a kind of dynamic line rating, but done with artificial intelligence in an indirect way, which means that it is not in order to measure the congestion or the amount of energy that can flow through a line. We can use it within artificial intelligence and not buying costly equipment that normally it is the case if you want to know this information. This is a technology that it is quite implemented at TSO level, but for medium voltage lines is not that mainstream, let's say. Also, we have advanced asset management for substations, but also for the different smart meters located in a whole grid, and grid planning methodologies in order to mainly avoid try to delay investments in the grid, mainly leveraging the flexibility that all the clients can provide. And finally, I want to mention the topology detection and upgraded state estimation. Here also we are using artificial intelligence mainly to detect the topology of a grid. Here we have two options or two branches, let's say. In one use case, we have the information of the topology itself, and we apply these technologies to better know which are the energized lines and energized branches, because in small DSOs it's not that usual that the traceability is well reported, and mainly they are not working with the proper topology of the grid. And the other point is when we don't have any information at all about the topology of the grid, because it is quite old or because it is not well reported. Also, it usually happens in very small DSOs. And here, just with the data from the SCADA and the smart meters, we try to map and provide a version of the topology of the grid. These are the technologies for the grid operators. Then regarding OPENFLEX, we have technologies to calculate the optimal flexibility that can be leveraged in a specific demand response actions. We have it with two different views: from the view of the, let's say, of the aggregator, which calculates which are the clients or which are the areas in which more flexibility can be extracted, and also from the point of view of the own client, in which we calculate the best assets and that can provide flexibility in a specific moment of time. Also, we have in the consortium nodes, which is an independent flexibility market operator with their own flexibility market, and we are adapting their, let's say, their current schemas in order to try to have new flexibility management schemas for the cases of Greece, Spain, and Switzerland, of course, leveraging their current platform. Here, one of the main or most important innovation is that they are proposing a use case in which there is a common flexibility market in which both the TSO and the DSO are participating. And finally, we have non-intrusive load monitoring algorithms, which mainly will be able to disaggregate the consumption of a whole household without the need of installing specific metering equipment. So we will know the consumption of our HVAC or our refrigerator just with artificial intelligence without the need of more sensors. Regarding OpenSpace, as mentioned, it is just a data space that will facilitate the data sharing between prosumers and the aggregators. We are using the process of Gaia-X, and we are, let's say, based on the work of two other European projects like DataCellar and Omega-X. And finally, we have OPENABILITY, which are methodologies for enhancing the interoperability between partners. They are not technologies or software developments themselves, but I think that this could be the most interesting at standardization level, let's say. One of we have two methodologies. The first one is a converter between topology models, because especially in small DSOs, the topology is mainly reported in complex Excel files, or it is not reported in a proper digital manner. And we have developed a converter in which we can use different ways of reporting this topology and convert it in another format. Our aim is we started this development in order to be able to have the topology in the CIN format, but it is also possible to have it in other formats. And then we will have, in an easy way, the topology integrated in a software platform, in a distribution management system. And also, we are developing a methodology in order to scan let's say, we propose that the manufacturers of assets provides a QR code with some information, and the end users will be able to easily scan this QR code and integrate the information into their home energy management systems, and this will facilitate afterwards the provision of flexibility, since we have the most accurate information in the own mobile phone of the end user. Just going with the two last slides regarding standardization. Of course, we are continually checking the activities of different standardization committees. UNE is in charge of this, and this is one of the reasons, I think, of us being here today. But at more technical level, at the standardization, main standardization actions, we can talk about the use of the IEC 62559 standard for the modeling of the use cases that we did at the beginning of the project, and also the use of SGAM for the architecture definition. Here, just a couple of sentences. The beginning of the project, we plan to use blockchain instead of data spaces in order to this data sharing, but for some reasons we modified our first approach and we moved to data spaces. So at the beginning of the project, we even had an idea to make an extension of SGAM with a blockchain layer. Here you can find some preliminary ideas about that. But finally, as we moved this scope to data spaces, finally we did not deliver it. We just delivered just a couple of pages with some preliminary ideas that may be of interest to someone as a very basic foundations of future work in this field. But well, just to mention that this was our initial ideas. And finally, regarding the development phase of the project and maybe post-project phases, well, we are trying to promote the use of CIM for DSO topology. CIM is mainly used for TSOs, but not that usually included at TSO level. And for that reason, we will try to promote the OPENTUNITY topology converter that I mentioned before. And finally, this methodology for the QR codes for extracting the flexibility information of an asset. Well, we have this idea, and we will closely follow the progress around the digital product passport, since probably it will have a lot of synergies, or maybe we can provide any kind of suggestion, best practices. We can feedback each other. I don't know, but we will closely follow this progress. And that's all from my side regarding the presentation of the OPENTUNITY project.